Hi all, this is Alan with Bothell STEM Coach, and today we're going to do some more calculus optimization problems. Again, these are more challenging examples than are on the AP exam, but if you're able to master these, you'll be able to master virtually any optimization problem you run into. So I have a steel pipe here being carried down a hallway 9 feet wide, and at the end of the hall there's a right angled turn into a narrower hallway 6 feet wide. What is the length of the longest pipe that can be carried horizontally around the corner? It's a tricky one. So they drew a picture here for you. That helps a lot. So basically what has to happen is this length. I guess another way to think of it is what is the longest that this part can be at any angle? You know what I mean? So if I were to draw different angles, what's the longest that line would be? So we want to find the length of this distance as a function of theta, and then decide what's the longest I can get out of there. So that's kind of the general strategy. I want an equation for the length of this based on the angle theta here. Well, we'll split this into two triangles, and we'll have L1 and L2. Now, L2, what's the relationship between L2 and theta? I know the tangent of theta. No, not tangent. Sine. I know sine of theta is equal to opposite over hypotenuse, 6 over L2. So L2 is equal to 6 over sine theta. Okay. And then for L1, what's the relationship? Well, this is the adjacent side. I know cosine of theta is equal to 9 over L1. So L1 is equal to 9 over cosine theta. So that means L1 plus L2 is equal to 6 over sine theta plus 9 over cosine theta. And we'll call this length L. This is what I want to maximize. I want to maximize what L is over various angles of theta. Because if I find what the longest distance here is, or maybe it's the shortest distance. It's the distance. Do I want the longest distance? No, I want the shortest distance because I want the distance that like any angle the pipe will clear. So I actually want the shortest of capital L. So I want to take the derivative of this with respect to theta. Okay, so 6 over sine theta. There's a couple ways you could do this. You could do this as quotient rule. I would really write this more as 6 sine theta inverse plus 9 cosine theta. I just prefer power rule and chain rule to quotient rule. That's just a preference. You could do it through quotient rule though. So this would be 6 times negative 1 times sine theta negative 2 by power rule for the negative 1 part. But then the inside's not theta, so I gotta do the derivative of this, which is by chain rule is cosine of theta, plus 9 times negative 1 cosine theta to the negative 2. That's power rule times the derivative of the inside, which is negative sine theta. And that's negative 6 cosine theta over sine squared theta. Minus is negative, so this plus 9 sine theta over cosine squared theta. So that's just a little bit of algebra, rearranging this stuff in algebra. And I want this equal to 0, so I want these equal to each other, if that makes sense. So like I bring this to the other side, so I have 9 sine theta over cosine squared theta is equal to 6 cosine theta over sine squared theta. I can cross multiply the sine squared and the cosine squared, so I get 9 sine cubed theta is equal to 6 cosine cubed theta. And then we'll do sine over, I divide by cosine cubed, so I get sine cubed theta over cosine cubed theta is equal to 6 over 9, which is, because I bring the 9 over to this side, 2 over 3. And this is just simply tangent cubed. So theta then equals well, let's just tan theta is equal to the cube root of 2/3. But I'm not actually looking for the angle it happens. I'm actually just trying to find the length. So what I'm trying to do then is then plug this equivalent theta back into here. Okay, see that? So L, which is 6 over sine theta, plus 9 over cosine theta. Well, I know tangent of theta is equal to cube root of 2/3. If I draw, the way you do this conversion to sine and cosine is I say, well, this is theta. I say tangent, which is opposite, is cube root of 2 over adjacent, which is cube root of 3. This would be the square root of this squared. So it's 2 to the 2/3 plus 3 to the 2/3. So, we're getting to some pretty complicated numbers here. Yeah, there's no real way to simplify that. So L is 6 over sine of theta. Sine would be opposite over adjacent, so it'd be cube root of 2 divided by the square root of 2 to the 2/3 plus 3 to the 2/3. Plus 9 over cosine of theta, which would be adjacent, which is cube root of 3 over square root of 2 to the 2/3 plus 3 to the 2/3. I don't think that this is really going to simplify any more, but I can because I'm dividing a fraction over a fraction, I can 6 times the reciprocal of this. 2 to the 2/3 plus 3 to the 2/3 over cube root of 2 plus 9 square root of 2 to the 2/3. I realize I'm making a total mess at this point. It's totally unorganized over cube root of 3. And that's not a very clean answer, but I think that gets you to the point. The point is the numbers just didn't work out like super great, and I wonder if I don't think I made a mistake in the math anywhere. Sine squared, cosine, sine squared, sine cubed, cosine cubed. Yeah, cube root of none of these are cube roots, so yeah, I don't think there's any easier way to do that. But hope you found that helpful in going through the process. Oh, the last thing we didn't check was whether this was min or maximum. But given the problem, this would have to be a minimum. Just because there's no, yeah, I think there's no other solutions. Are there? Yeah. Yeah. Now I'm doubting myself real quick. I'm just checking if yeah, I think that's right. Anyway, hopefully you get the setup at least. You understand the setup. This is a pretty tricky question. The setup is about setting up an equation that relates to a variable you're interested in and then taking the derivative set equal to 0 to maximize the problem. So hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.